This video is going to look at the multiple representations in which you will find slope-intercept form of a line. So a review of slope-intercept form, if you have a function in slope-intercept form, we're going to write that in mx plus b, where m is your rate of change and b is that initial starting value, or what we're going to plug in, or what the output is, I should say, when x equals 0. Let's look at our first example. So as you go deeper in water, the pressure on your body actually increases. And so the pounds, or the pressure in pounds per square inch, the PSI on a diver, depends on her depth below the water, and that we're going to call that depth D. This relationship is modeled by this function, right here. So we're going to restate this. We're going to say pressure increases by 0.434. And it doesn't really give the units here. We need this in pounds per square inch per foot is what it is. It's PSI per foot. And I know that because in my equation right here, I'm going to multiply m by the number of feet, right? And I'm going to multiply that slope by the number of feet. And the result that I need is PSI, which means slope must be in PSI per foot. So pressure increases by this amount, or we could say PSI per foot instead, so that it's in words there, with an initial pressure of 14.696 PSI. All right, we can also find the equation of a line. So we have some words that we can use. We also have graphs that we can use in finding the equation. So in that y equals mx plus b, I need two things. I need the slope, which from a graph is going to be rise over run. And I need the initial start, or I need what's going on at x equals 0. So I have that here, 0, 7, so b must be equal to 7. And then I can use rise over run. Starting from the leftmost point, I actually rise negative, so -3, run 4. So m must be equal to -3 over 4. And so the equation of this line in slope-intercept form must be -3/4 x plus 7 is equal to y is equal to our outputs. All right, let's look at an example if I have a table. Now, linear functions need to increase the same amount per unit of the independent variable. So notice in my table here, w increases by 2 each time, and the number of rats increases by 80 each time. So if I need to figure out the change in the number of rats over the change in the number of weeks to find my rate of change, I'm going to make sure that I do 80 over 2, which is 40. Now, where a lot of students get confused on tables is our x variable usually goes on top and our y goes on bottom. But when you find slope, we do change in y over change in x. And so you kind of have to reverse those two numbers. And it should make sense that we're looking at how many rats are added each week, not weeks per rat, but rats per week. So that's going to be my units here. I also have my initial right here, my 0 when W equals 0. It looks like the population is 1,000. And so I can write this, I'm going to write it in function notation. So it gives me P of W equals 40W plus 1,000. All right, I have already gone from graph to equation. We can also go from equation to graph. So in this case, plus B. I can map the equation that's given to me in function notation to what I would know from the equation of slope-intercept form. So in that case, that means m equals -2/3, and b must be 5. Now remember, b of 5 means that when x equals 0, my output is 5. And then a slope of 2/3 means I go down 2 points in y for every 3 points of x. And to graph a line, all you need is 2 points. So once you have those 2 points, you are good to go. All right, here's a little bit of a trickier equation. I don't give you b in this one, so we're going to have to solve this for b. The first thing I want to do is find the slope, and I'm going to do that by finding the change in y over the change in x. Now, when this is written in function notation, sometimes I find it easier to write it in point form. So that's the point 3, -2. And this is the point 8, 1. Or when I plug in x equals 3, I get a y of -2. So let's call that our first point. And when I plug in x equals 8, y equals 1, let's call that our second point. So y2 minus y1 over x2 minus x1. I'm going to end up getting 3. 1 minus -2, that's the same as adding. And then 8 minus 3 is 5. So I know in my slope-intercept form that m is equal to 3 over 5. The question is, how do I solve this for b? Well, I could plug in either one of these 2 points that are given and then just solve this for b. So I'm going to choose this one. Eight is the same as 8 over 1. So I'm going to change this to 24/5 plus b. And then I'm going to subtract 24/5 on both sides. If I change 1 to be 5/5 so that I have the same denominator, then I'm going to end up having -19/5 for b. So not a nice intercept, but I can then just plug this back in. So 3/5 x minus 19/5 for my answer here. That one's a little bit trickier. I could have done the same thing with the other point. I don't know that it would have been any nicer. I think you still would have gotten, you should have still gotten the same b value if you plug that in instead.